Now let's look at this one. Which region contains the coordinates of the points that satisfy the given system of inequalities? The first equation is the circle, and I want to see, do I shade inside the circle or outside the circle? To figure that out, I'm going to use the point 0, 0. The point 0, 0 is inside the circle, and so I'm just going to check and see if that works in the circle equation, and then I'll know if I should shade inside or outside. So I'm going to try 0, 0 in the circle inequality. So 0 plus 0 is less than or equal to 16. That is true. And so I should shade inside the circle. So I'm going to put some arrows to remind myself that I want to shade inside the circle, because that point, 0, 0, worked. And that tells me that every point inside the circle is going to work in that inequality. All right, now for the line y greater than or equal to x, I'm not going to use 0, 0 because 0, 0 is on the line, and I want to know, should I shade above the line, that is to the left of the line, or below and to the right of the line. So I need to choose a point that is not on the line. So I'm going to try negative 2, 2 for the line, since it's already on there. Negative 2, 2 for the line. Okay, that point is above and to the left of the line. So if that point works in a linear inequality, then I'll know that's the side of the line I should shade. If it doesn't work, I should shade the other side. So I'm going to try it. Y greater than or equal to x. So 2 is greater than or equal to negative 2. That is true. And so I should shade that side of the line, above and to the left. And so if I look at both of those things inside the circle and above and to the left of the line, then I am talking about section B. So B would be my region that I would shade. All right, now we're going to start talking about phase shifts and periods of sinusoids. So far, when we have written the equation of a sinusoid, we have had sines and cosines where they are always centered. They're always kind of in the same place of horizontally, and they have just been moved vertically, and they may have a different amplitude, but those are the only things that have been different between each one we've done. Now we're going to start seeing what happens if you shift the sinusoid left or right, and if the period of the sinusoid changes, which we'll talk about what that means in a second. But first of all, let's just review how to write the equation of a sinusoid. So if I want to write the equation of the following sinusoids, here's what I do. First of all, I say, should I write this as a sine or a cosine? Well, I'm going to write this as a sine because I can see that the function, the curve, is passing through the origin on its way up or down. That's how I can tell whether I want to write it as a sine or a cosine. If it's going through the origin, if it's crossing the y-axis on its way up or down, then I know I'm going to write it as a sine. So for this one, it's going down as it goes through the origin there. So I'm going to write it as a negative sine function. I explained that. The midline, the line that goes horizontally right through the middle, is y equals negative 10. So that's going to be what I add to the function. And then I can see that the amplitude is 4 because I'm going from negative 10 up to negative 6 and negative 10 down to negative 14. So negative 10 is right between negative 6 and negative 14. So it's 4 away above and below, and that's my amplitude. And so I can write that equation, y equals negative 10, that's the midline, minus, it's a negative sine function, 4 sine theta. The 4 goes right in front of sine. That's telling me the amplitude. Okay, So the second one here, we would want to write this as a cosine function because we can see that it is at its maximum when it crosses the y-axis. And so it's at the top of the hill. It could be at the top or the bottom of the hill, and we would want to write it as cosine. Since it's at the top of the hill, we're going to write it as a positive cosine function. So the midline, if you take a look, is at -8. And it goes up to -5 and down to -11, which means the amplitude is 3. And so we would write it this way. We would say y equals -8, the midline, plus 3, that's the amplitude, times cosine theta. So now we're going to see what happens if the sinusoid has been shifted left or right. So if we remember about translating graphs, when you shift a graph horizontally, you move it right or left, that is when you add or subtract something from theta or x. If I shift the graph of y equals sine theta 45 degrees to the right, then I'm going to subtract 45 degrees from theta. So my equation becomes y equals sine quantity theta minus 45. So if I did that, if I subtract 45 from theta, I scoot the graph over 45 degrees to the right. So it looks exactly the same, except that now, instead of going through 0 here, it goes through 45 degrees. So I shifted it 45 degrees to the right by subtracting 45 from my theta or my x, my independent variable. We would say it has a phase angle of positive 45 because that's where the graph crosses that horizontal axis. Okay? If I shift the graph of y equals sine theta 45 degrees to the left, I have to add 45 to theta. So my equation becomes y equals sine of the quantity theta plus 45. That shifts the graph to the left. Since the graph itself has been shifted 45 degrees to the left, we say that the phase angle of the graph is -45. So the phase angle for a sine curve is the angle nearest the y-axis where the curve crosses the center line. And the reason for that is that normally with just a regular sine function that doesn't have a phase angle, the function crosses the y-axis right there on the center line, the midline. But for a phase angle, that will be to the left or to the right of the y-axis. And wherever that happens, the closest place that happens, that is your phase angle. So for a positive sine function, you're going to be looking for where that happens when the graph is going on its way up. Okay, this all works the same with the cosine function, except now the phase angle is the angle nearest the y-axis where the graph has its maximum. So normally when we are writing the equation of a cosine function, that maximum happens right when it crosses the y-axis, in the middle of that mountain, that top, that hill. Now, wherever that happens, to the right or left of the y-axis, the closest place, that is going to be the phase angle. So for this green graph, we have added 45 to theta in our equation, so it has moved the graph left, and the phase angle is -45 degrees. All right, so we're going to write some equations. So here's a sinusoid. We can write it as a sine or a cosine. They look exactly alike. It just depends on where you put the phase angle, and that's really the only difference. Because a sine function looks just like a cosine function. It's just been scooted over one way or the other. So if we're going to write this as a sine function, then we are looking for the place where this crosses the midline on its way up. And first of all, the midline is 4. That's the midline is y equals 4. That's going right through the middle. And then we know that it goes up to 6 and down to 2. So the amplitude is going to be 2. From 4 to 6 is 2. From 4 to 2 is 2. And then we need to talk about the phase angle. Like I said, So if we're looking at writing this as a sine function, we're looking at the place where this graph crosses the midline on its way up. And you can see that is happening at negative 60. So the graph has been scooted to the left 60 degrees. And to do that, I'm going to need to make it theta plus 60. So the phase angle is negative 60. The graph has been translated 60 degrees to the left of where the basic sine function would normally be. So we add 60 to theta in our equation. So y equals 4, which is the midline, plus 2, which is the amplitude, times sine quantity theta plus 60. Okay? If I want to write this graph as a cosine function now, the midline is still 4, hasn't changed. The amplitude is still 2, that hasn't changed. But we're not looking now at where the graph crosses on its way up. We're looking at the maximum of the graph. We're looking at the top of the hill. Where is that happening on the x-axis? And that is happening here at 30 degrees. So the graph is at its maximum when theta equals 30. So the phase angle is 30 degrees. And that means that the graph has been scooted 30 degrees to the right. And that's 30 degrees to the right of where just a basic cosine function would be. So we need to subtract 30 from theta in our equation. So y is equal to 4, which is the midline, plus, oops, sorry about that, plus 2, the amplitude, times cosine, and cosine of the quantity theta minus 30 degrees. Pretty straightforward. We'll do one more here. We're going to write the equation of this function as a sine curve with a phase shift. So they often in the book, they will tell you whether to write it as a sine or a cosine. So we're supposed to write this as a sine. And so when we write it as a sine, we're looking at the place on the graph where it is on its way up as it crosses that midline. So here is where that's happening, right here at negative 90 degrees. So that is going to be my phase shift. Phase shift is negative 90, which means I'm going to have to add 90 to theta when I write my equation. Now, the midline, you can see right there, is negative 6. So midline that's actually the line y equals negative 6. And then it goes up to negative 5 and it goes down to negative 7. So the amplitude is just 1. From negative 6 to negative 5 is 1. From negative 6 to negative 7 is 1. So the amplitude is 1. So we have everything we need. So we're going to write this as y equals negative 6, that's the midline, plus 1 times sine. We're not going to put the 1 because we don't need to. So it's going to be sine, but instead of theta, it's going to be theta plus 90 because we have scooted the graph over 90 degrees to the left. All right, now we're going to another thing that could happen to a sine or cosine function that would make you have to write the equation differently. So sinusoids are called periodic functions because they repeat over and over again. They just keep going up and down and up and down, looking exactly the same. The number of degrees or radians on the x-axis, on the horizontal axis, that it takes for the function to complete one full cycle of all the values it goes through is called the period of the sinusoid. So far, all of our graphs have had periods of 360 or 2 pi radians. When the independent variable, that is theta or x, is multiplied by a number greater than 1, the graph will complete its cycle more quickly and the period will decrease. So what I mean by that is if you have y equals sine theta, it's going to look like that red graph takes 360 degrees to go through all of its values. Okay, so I'm sorry to say that this equation is written incorrectly, so please scratch that out. It should be y equals sine 2 theta. So please fix that. So as I was just saying, when theta or x is multiplied by a number greater than 1, the graph will complete its cycle more quickly and the period will decrease. Okay, so what do I mean by that? That sounds confusing. All right. Normally, when you just have y equals sine theta, look at this red graph. It's starting here at 0. It goes up to 1. It goes back down to 0. It goes down to -1, comes back up to 0. It has now completed all the values that it ever has. From 0 to 1, back to 0, back to down to -1, and back up to 0 again. Now it's just going to repeat that again. All right. It took 360 degrees for it to do that, for it to complete all those values. That is what I mean when I say that that function, y equals sine theta, has a period of 360 degrees. It takes 360 degrees for it to do its thing that it just does over and over again. Now, if you have y equals sine 2 theta, that is, if you multiply theta by 2 in your equation, then the graph starts going more quickly. The what you would call the frequency has been raised, all right? Because now the graph, if you look at the dotted graph here, if you start at 0, that graph goes up to 1, down to 0, down to -1, back up to 0, completes all of that stuff in less of the x-axis. It only takes 180 degrees for it to happen. So it will, if you look at that too, what that kind of tells you is that this particular curve will complete 2 cycles in 360 degrees. It's going double time. And so that means that the period has decreased. Now that sounds confusing, right? The period decreased because now the period is 180. Because the period tells you how many degrees does it take for the graph to do all of its values from 0 to 1 to 0 to -1 back up to 0. It only takes 180 degrees for that to happen in the dotted blue graph, y equals sine 2 theta. So when you multiply your theta or your x by a value greater than 1, 2, 3, 4, 5, 6, whatever, what happens is your period is going to decrease. The graph will complete a cycle more quickly, and therefore that cycle, it will complete one cycle in less than 360 degrees. So you can see, if you can see it here, you might not be able to see it, but down at the bottom, it says that the period when we have y equals sine 2 theta is 360 divided by 2. So if you divide 360 by that coefficient of theta, that is going to tell you the period. So the graph of that dotted blue curve has a period of 180 degrees. Okay? When the independent variable, that's theta or x, is multiplied by a number between 0 and 1, so like 1/2 or 2/3, something like that, then the graph will complete its cycle more slowly and the period will increase. All right? So, as we were talking about before, normally we have y equals sine theta or sine x or whatever, and that takes 360 degrees to go through all of its values. Starts at 0, goes up, goes back down, all the way down to -1, going back up again to 0. It has now completed all of its stuff, and that graph right there is y equals, I can't even see what the horizontal axis actually is here, but anyway, that is y equals sine theta. It takes 360 degrees to do its thing. Now, if I divide or if I multiply theta by a number between 0 and 1, like 1/2, here I have y equals sine 1/2 theta or x or whatever that horizontal axis is. That is going to slow the thing down. The frequency is going to drop. And now it doesn't even complete one whole cycle between 0 and 360. It only completes half a cycle. So it's going up to 1. It's going back down to 0. It's going to take another 360 degrees for it to get back down to -1 and back up to 0 again. So this graph takes a whole 720 degrees to complete one cycle. And so you can see that the period has increased because it takes 720 degrees to complete a cycle. So when you multiply theta or x by a number between 0 and 1, the period will increase. And so to figure out what the period is, you would say, all right, again, you would still say that the period is equal to 360 divided by whatever that coefficient on theta is. In this case, it's 1/2. And so that is 720 degrees. All right. Well, first of all, in general, we see that the coefficient of the variable is 360 divided by the period in degrees, or 2 pi divided by the period if you're in radians. So when I say the coefficient on the variable, I mean whatever you're multiplying theta by in your equation, that number is 360 divided by the period. So when you're getting ready to write your equation, you have to figure out what the period is, so you'll be able to know what coefficient you're supposed to put on theta in your equation. All right, so if we want to write the equation of this first curve here, we can see that we want to write it as a sine function because it's passing through on its way up as it crosses the vertical line there, as it crosses the midline. It's going up right there. So they're not, at this time, they're not going to give you a phase angle and a period change at the same time. They'll either give you a phase angle or they'll give you a period change. So you don't have to worry about doing both of those at the same time. So we can see that this doesn't have a phase angle. It's doing exactly what a sine function usually does. It goes right through, crosses right over the vertical axis, the y-axis, as it's on its way up, crossing the midline. So first of all, let's just go ahead and see. We can see that the midline here is positive 10 right there. We can see that the amplitude, it goes up to 12 and down to 8. So the amplitude is going to be 2. Sorry. The horizontal axis, like I just said, is 10. The phase angle, there is not a phase angle. Now the period, that's the question. How long does it take this graph to complete one full cycle? Well, it goes up, down, and back up. It only takes 90 degrees for it to do that full cycle. So the period is 90 degrees. So when I'm writing my equation, I need to know what coefficient am I supposed to put on my theta. Well, let's just go ahead and start writing the equation. Y equals, okay, the middle line, the horizontal line that goes right through the middle is 10. So that's here. Plus the amplitude is 2. So 2 times sine what? Well, there's no phase angle, so I don't actually need parentheses right there. But I need to put a coefficient on theta to tell me that the period is 90. And to do that, I just need to know this. 360 over the period is that coefficient. So 360 over 90 times theta is what I'm going to have here. So y equals 10 plus 2 sine 4 theta. That's my equation. So another way to think about this is whatever that coefficient on theta is tells you how many times the function completes a cycle between 0 and 360. And you can see, if you look at the graph, that happens 4 times. Here's 1 cycle, here 2 cycles, 3 cycles, and 4 cycles. So it takes 360 degrees to complete 4 cycles. And so that's the coefficient on theta. But you may be able to remember this more easily. To find the coefficient on theta, you simply divide 360 divided by the period. The period is 90 degrees. How long it takes this graph to complete 1 full cycle. Okay, let's look at this one. You can see that we're going to write this as a cosine function because the top of the little hill is right there crossing the vertical, the y-axis as right in the middle of that hill. Okay, so now the question is, what is the amplitude? Well, we can see that the midline is at 10 and it goes up. Well, it's actually negative 10. So I'm just going to write that first. The horizontal axis is at negative 10. We can see that it goes up to negative 7 and down to negative 13, which means that the amplitude is 3 because negative 7 is 3 away from negative 10, and negative 13 is also 3 away from negative 10. There is no phase angle. As I said, they're not going to do a phase angle and a period at the same time, so not applicable. The period is how long it takes the function to complete 1 full cycle. And so that starts right here, goes down, back up again to where it began, right here. So we can see that it takes pi radians for that to happen. 1 full cycle happens in pi radians. So the period is pi. All right, so to figure out the coefficient that I'm going to put on my theta, I would need to say 2 pi divided by the period, which is pi, and that is just 2. So when I write my equation, I'm going to have y equals the midline, negative 10, plus 3, the amplitude, times cosine, and it's going to be 2 theta. Okay, moving on. Lesson 58, the distance from a point to a line. All right. So when we say the distance between a point and a line, we mean the perpendicular distance, which is the shortest distance. So if you have a point here, like this point P, and you want to know the distance between P and this line, you are talking about the perpendicular distance, straight down to the line, shortest possible distance. This point, to find the equation of the line through P, which is perpendicular to our line, we use the opposite reciprocal slope and plug in negative 3, 5. So the first thing we have to do, if we're going to figure out the distance between P and the line, is that we need to find out where that segment crosses the line. What is the point of intersection? Because remember, when I find the distance between 2 points, this point is negative 3, 5. I need to know the coordinates of that point so that I can use my distance formula to find out how long that segment is. In other words, what is the distance between the point and the line? So to find out what that point is, where these 2 lines intersect, I am going to use I'm going to talk about the slope of the red line, and then I know that since these 2 lines are perpendicular, the slope of the line that goes from P, the blue line, down to the red line, I know the slope of that is going to have to be the opposite reciprocal of the slope of the red line. So the red line is y equals 1/2 x plus 1. So I know that the slope of the blue line is going to have to be negative 2/1 or negative 2. The blue line is going to be y equals negative 2x plus b. Now I need to find out where b is. I know that the point negative 3, 5 is on the blue line, so I will plug that in. 5 is my y, negative 2 times negative 3 plus b. So 5 equals 6 plus b, so b is negative 1. So this blue line here is y equals negative 2x minus 1. So I now have the equations of the two lines. Y equals negative 2x minus 1 and y equals negative 1 half x plus 1. So this line, y equals 1 half x plus 1. So to figure out this point right here, I need to solve that system of equations. And to do that, I'm going to use substitution. Y equals 1 half x plus 1. So therefore, if I plug that into this equation right here, I'm going to have 1 half x plus 1 is equal to negative 2x minus 1. If I subtract 1 half x on both sides and add 1 on both sides, I'm going to have 2 is equal to negative 4 halves minus 1 half is negative 5 halves x. And so x is going to equal, that point has an x coordinate of negative 4/5. The y coordinate, I'm going to have to plug that back in to one of these equations. So I'll plug it back into the first equation. So y equals negative 2 times negative 4/5 minus 1. So that is 8/5 minus 1. 8/5 minus 5/5 is 3/5. So y equals 3/5. So here is the point of intersection. Negative 4/5, 3/5. We're almost done. We just have to find the distance between P, negative 3, 5, and the point on the line, negative 4/5, 3/5. To do that, we will use our distance formula and plug that all in. So we've got negative 3 minus negative 4/5, which is plus 4/5. And we're going to square that. And then we have 5 minus 3/5, and we're going to square that. This will be the distance from the point P to the line. And I have made such a big mess here. I'm so sorry. Let me just this all the way down here. All right, so that is the square root of negative 3 plus 4/5. That's negative 15/5 plus 4/5 is negative 11/5. And we have to square that. And then we have 5 minus 3/5, and that is 25/5 minus 3/5, which is 22/5. And we need to square that. And that's a big mess. So that is 11 squared is 121. 22 squared is 400 and something. 484. And 5 squared is 25. So 121 plus 484. You take the square root of that, it's irrational. So that is going to be the square root of 605 divided by 5. We're talking about narrow and wide parabolas. So we remember, hopefully, that the basic equation for a parabola looks like y equals a times the quantity x minus h squared plus k, where hk is the vertex. And what we're going to find out is that if a is positive, the parabola is going to open up. And if a is negative, the parabola opens down. We already knew that. But so far, we've only dealt with the possibility of a being positive 1 or negative 1. But if a is a number other than 1 or negative 1, the parabola will be wider or narrower than normal. So you can see here that we have y equals, for the blue parabola, we have y equals negative 3 times the quantity x minus 1 quantity squared plus 2. All right, this has the vertex 1, 2. and it opens down because that 3 is negative. But now the parabola is skinnier than normal. If you have a number here for a whose absolute value is greater than 1, then it's going to make your parabola narrower. If the number, however, like in this green parabola, is a number whose absolute value is between 0 and 1, then your parabola is going to be wider. It's going to be fatter. All right, let's look at some examples. All right, first of all, in order to write the equation of a parabola in standard form so that you can see what's going on there with the vertex, etc., you have to complete the square. To do that, first of all, you want to get y on one side and all the other values on the other side. So for this parabola, we're going to first of all leave that y over on the left side and move everything else to the right side. So we'll have a positive x squared minus 2x minus 5. We are going to complete the square on the right side so that we can get x minus h quantity squared plus k. So to do that, we will write x squared minus 2x plus blank minus 5, and then we're going to subtract that same value, whatever we put in that blank. The number that goes into that blank is half the x coefficient squared. So half of 2 squared, half of 2 is 1, square it, and that's 1. We're going to add 1 and subtract 1. So just a reminder, the number you put in the blank, let me write that somewhere. I'll write it way down here. You add and subtract half the x coefficient squared. So you take half and then square it. You add and subtract that when you're completing the square. So 3y is equal to, now this part right here can be written as a perfect square binomial, and that will be x minus half the x coefficient, which is 1, squared. And then you've got the negative 5 and the negative 1 over there, so that's minus 6. Now, we don't want 3y equals something. We want just y equals something because that's what the equation of a parabola looks like. So we're going to divide both sides by 3. And when we do that, we're going to have y equals 1/3 times x minus 1 quantity squared minus 6 over 3, which is 2. So we left that 3y on the left side. We didn't do anything to it. We just left it alone. And then once we completed the square and got all that done, we can now divide the two terms on the right by 3 to get y by itself. Okay, so I can see here that the vertex is going to be 1, negative 2, because I've got my h here and my k here. So vertex is hk. So 1, negative 2. Let's go ahead and graph that right there. And so the vertical axis goes right through there. And I can try some points just to figure out kind of what this parabola is going to look like. It's going to be fatter, we know, because we're multiplying by a number that is between 0 and 1. So it's going to make the parabola wider. So I'll try a value that is easy. If I put in something that when you square it, it will be divisible by 3, that's my best option because that way I don't end up with any fractions. So let's see, if I put in 4 for x into my equation, I'll have y equals 1/3 times 4 minus 1 quantity squared minus 2. And that is going to be 1/3 times 3 squared minus 2. And that is going to be 1/3 times 9, which is 3 minus 2, is 1. So the point 4, 1 is on this parabola. So that's right there. And then I know this parabola is symmetric about the line x equals 1. So and my line is not very good here. So try to make that a little straighter. So this is my axis of symmetry, goes right through the vertex. So since that point is 3 to the right of the line, there's another point 3 to the left, 1, 2, 3. And so my parabola is going to, well, it's just really bad, but it's hard to graph things like this. Anyway, it's looking something like that. Okay, we want to complete the square to graph this parabola. So to complete the square, we have to have a leading coefficient of 1, and we have right now 2x squared. So we're going to have to divide everything by 2. So when we do that, we're going to have 1/2 y is equal to x squared plus 6x plus 17/2. To complete the square, we're going to leave the left side of this equation alone. And we're going to write x squared plus 6x plus blank plus 17/2 minus blank. Okay, so the tricky part here is you don't want to do anything to the left side of the equation. Leave the left side of the equation alone until the end, because if you try to mess with it now, you could cause all kinds of problems. So let's just deal with the right side and get the square completed and all that. So to complete the square, we're going to take half the x coefficient and square it. So half of 6 is 3, squared is 9. Add 9 and subtract 9. When you do that, you're going to end up with 1/2 y is equal to the quantity x plus, and remember it's half the x coefficient, which is 3, squared. That's this whole thing here. This perfect square trinomial can be written in that way, x plus 3 quantity squared. And then you have 17/2 minus 18/2 is just going to give you negative 1/2. So now we're done. We've completed the square, and now we can multiply both sides of the equation by 2 to get y by itself. So y equals 2 times x plus 3 quantity squared, and then that is minus 2 times 1/2, which is just 1. So -3, -1 is our HK. And so let's do that. Let's go -3, -1 is right here for the vertex. The vertical, the line of symmetry is right there through the vertex. And then if you plug in the point -2 into the equation, you are going to get y equals 2 times -2 plus 3 quantity squared minus 1, and that's going to give you 2 times 1 squared minus 1, which is just 2 minus 1, which is 1. So -2, 1 is on the graph, which means that -4, 1 is on the graph because it's symmetric about the line of symmetry. And so you can see now that this parabola is skinnier than normal. So anytime you have a coefficient greater than 1 in front of the perfect square binomial, then you're going to have a skinnier parabola like this.